Christoph and Urs. Happy to have you and good luck with your presentation.
Okay. Dear audience, thank you for the opportunity to give a presentation here with my colleague Urs Grunicke. My name is Christoph Antoni, and I'm working for the ASFINAG in the Department of Asset Management as expert for engineering structures. In the first part of the presentation, I will give a brief overview about ASFINAG and the key facts of the Austrian tunnels in the highway network. In the second part, Urs will talk about a research project on the subject of life cycle management of tunnels. So, ASFINAG operates all of the motorways and expressways in Austria. It manages the planning, building, and refurbishment of the road and its infrastructure, and it's responsible for the so-called asset management cycle. And we are focused to keep our routes available and secure. Next slide, please, Urs. Yes, as you might know, Austria is a quite mountain. The road infrastructure contains a relative high amount of bridges and tunnels. 10% runs through tunnels of the roads, and the total length of the tunnel tubes is about 400 kilometers, in reference to 2,000 kilometers lane kilometers. Mostly, there are 2 tunnel tubes, one for each direction. The longest tunnel is the Adelberg tunnel. It connects Vorarlberg with Tyrol, and it's 13 kilometers long. This is one of the last single-tubed tunnels in Austria. The Department of Asset Management carries out the inspections of tunnel. The purpose of these inspections is, on one hand, to ensure the legal obligations, and on the other hand, inspections form the base information to create a workable construction program. For this, various information about the condition ratings of infrastructure is to be collected in good quality and consistency. Now, to some further information of the tunnels. On the first picture, on the left side, you see the age distribution of the tunnels. The vertical axis shows the length in kilometers of the length of the tubes, and the horizontal axis shows the year of commissioning. As you can see, there were 2 waves of construction of tunnels. In the second wave, many single tube sections were expanded by a second tube. The expansion of the tunnel tube on the existing network was completed 2019 as part of the execution of the EU Tunnel Safety Directive. On the other diagram, on the right-hand side, you can see the development of the tunnel condition divided into 5 classes, from a very good to very poor condition. Due to maintenance measures as part of the tunnel safety program, the proportion of tunnels in fair, poor, and very poor condition was reduced in recent times. Please, the next slide. And this diagram shows the expenses for tunnel repairs. Due to tunnel safety program, a large proportion of the total expenditure was invested in electromechanical equipment in recent years. In the next years, an average of 80 to 100 million euros are invested into tunnel maintenance works. Because of this, it's very important to have a plan and to make fact-based decision-making possible in an early stage of the planning process. In order to develop new approaches here, a research project for the optimization of maintenance works in tunnel was launched. And at this point, I will hand over to Urs, who will present us the results of the project. Thank you till now, and I will switch now to Urs.
Yeah, much, Christoph. Good afternoon from my part. How exciting it is to be here in this session marathon this afternoon. Referring to the speakers in earlier presentations in these Belgian sessions, asset management is more than project management, and as Laura said, okay, you can triangulate it with different objectives. And I would even go a step further. I would say there is more objectives to asset management. Of course, there is always costs. There is safety issue. There's the issue of level of service. But as Christoph impressively showed, we are spending here several hundred millions of euros in 5 years and so. So what about accountability? So we need to make our decisions based on evidence. So that's a requirement in asset management, to make fact-based, evidence-based decisions, as also Natasha showed when she presented her BIM strategy. And since our decisions and measures take effect in the future, we need to be able to predict the performance of our assets and how we deal with them. And the further we look into the future, the more the issue of uncertainty and reliability arises. Not only reliability in the present stage, but how reliable will our assets be in the forthcoming future. So, and that's the scope of this research program Christoph mentioned, this program Optimal, where we try to encompass all those objectives into one decision support tool called Optimal. Road tunnels and rail tunnels are basically the same issue here. They're more than just a one-dimensional concrete tube, as you definitely know. There's numerous assets or sub-assets in there. In Austria, let alone in Austria, we talk about 52 different components and sub-assets. That means 52 different materials, 52 different service lives. And now as an asset manager, you have to ask yourself, okay, how do I make my maintenance? How often do I go in there? Because if you close the tunnel every year, once one of those assets it expires and has reached its end of service life, you will end up with a very, very bad level of service. So you need to bundle, of course, those measures. And as if this was not already challenging enough, all these different assets are interacting with each other, not only in the function, but it's usually more the rule rather than the exception. Then when replacing an asset, you usually can do that only when also touching another asset, even renew it, even though that other asset hasn't even reached its end of service life yet. So you would give up on some service time for that. This means that there is a lot of collateral measures when you actually want to do maintenance on only part of the assets. And you need to be able to address and assess the amount of those collateral assets. That can become quite complicated, actually, because of this numerous interaction. But you can model that rather easily in a matrix, where you can easily formulate the degree of interdependencies. And with this matrix, it is possible to assess those collateral measures. And it also gives quite a good idea about the topology of the system and what are the central assets that interact with a lot of other assets. Also, in terms of a RAMS process, in terms of maintainability, that's also quite a benefit for that. Okay, but this doesn't already answer the question: what is the optimal maintenance cycle? If you draft all your asset renewal efforts on the timeline, just as they occur, depending on their service life, you would come up with something like this, and without bundling them in the beginning. And you will see in this example, which is typical for an Austrian highway tunnel, that every 20 years or so, there is a concentration of efforts here in the year 20, 40, 60, and so on, just by the natural expiration of service life. So you could call that the heartbeat of the system. And why not take those 20 years as a starting point by saying, yes, let's make a 10 years maintenance cycle. And every asset that expires in between, we delay the measures for another 5 years, or to make them earlier. If we make them earlier, of course, that comes at the cost of giving up some service life. And if you delay them, of course, it comes at the cost of of a reduced reliability, maybe because the component is older and has more faults and defects. And you need to be able to address that. So it involves a bit of prediction and looking into the future in the long term and short term. And looking into the future is not rocket science. That basically it's rather straightforward, even though the mathematical background appears to be sometimes a bit complex. And it can be frustrating at times to collect all the data. But usually the data is there. The challenge in this context is that data, for example, for ventilation, is somewhere else and in a different format than the data on the concrete lining. And to integrate all that data, that's just a piece of homework you have to do. And not every data not every asset has the data to the similar amount of data, but basically it's better to have crude models with few data than no degradation model at all. Because if you don't use a prediction model, basically you're flying blind. And that's not what we want to do in accountable asset management, do we? Yes, future and reliability. Reliability, or to put it differently, the risk of unscheduled downtimes. How can we assess that? Basically, this is risk management. You can make that relatively easy, actually, as well, in terms of a qualitative risk assessment. Risk, as you know, is a product of probability and consequence of failure. And here we are talking about the probability of unscheduled downtimes due to aging components. And the probability of failure is basically a function of its condition. And since we already have the prediction models, as I said earlier, we are also able to predict with a certain degree of uncertainty, of course, the probability of a failure in the future. And of course, it is also influenced by some other aspects like how closely we monitor our assets and how well we know about our assets at all. And digitalization, of course, helps in that context. The consequence, we found that it's the most straightforward to measure the consequence of unexpected downtimes in terms of the duration of downtime of the disturbances. Are we talking hours, days, or even months? Is the disruption causing a complete closure of the tunnel, or can we still operate it in a reduced mode? How much traffic is involved? Are there diversions possible in the network? The criticality and resilience of the network? And rather trivial things, but as well not less important, especially for safety equipment. What about spare parts? Do we have them in stock, and how quickly can we have them on site for repair? Yes, so let me summarize. We have captured the system topology and the dependencies between the assets, so we don't run into the risk of forgetting the necessary collateral measures. We have collected all our data and evidence to find prediction models for the performance of our assets in the future. And we have found a way to define and assess reliability of our assets and the performance of the reliability for each single asset and the collective asset in the tunnel system, and even for the entire tunnel portfolio. So now, what we made with all these stones, we came up with this framework, which allows us to have a holistic asset management. And with this toolbox, we can now build maintenance strategies and maintenance plans, both on strategic and operational level, and compare them against our strategic objectives. The framework is basically ready for implementation, which I'm sure will happen within the next coming months. And the beauty of it is that we can already do it today. So we don't need to wait impatiently until we have a full degree of total digitalization. With all the things we have at hand, we can already start making our decisions. And now imagine the potential once we have total digitalization that unfolds once we have it all more or less just a click away. I'll be happy, and Christoph and I will be happy to answer your questions. Thank you.
Hello, so do we have any questions? Please write them in the discussion forum. Well, I will start with the first question. When you talk about, yeah, we are ready to implement it. We are ready to indeed to start. From your side of view, you have a good vision on indeed the approach. How do you see it for the asset manager himself? Do you have for the moment a clear communication? Do they really are already into this approach, or is this also something which needs to grow in the future?
If I may, it is mostly a question of governance, not so much about technical issues. Of course, and also as Laura already showed and Natasha earlier, you have to start off with an asset management policy and your objectives, and then break it down into detailed objectives for your asset types, such as tunnels and bridges. And there's a very long and very profound tradition in strategic asset management in Haezendonck with pavement and bridges, for example. And then the degree of maturity in tunnels still has some potential there. And this process is at the moment a very exciting and interesting negotiations we have with the different stakeholders in the different departments and organizations. And actually, that's the exciting thing about asset management.
Yeah, thank you.
And from the view of Haezendonck, we want to implement new approaches but it will need time for us to completely understand what does the risk assessment mean for us, and how can we interpret the results of it.
Yes,
of course.
Okay, thank you. We have a question of Ruben van Quali. You just listed the components of damage. Could you discuss how you evaluate those and how you concluded that the components are multiplicative?
I'm not sure if I understand the question completely, but I'm going to give my best, of course. What damage or the condition of the elements or the sub assets are graded in the grading system. I think that's common all over Europe. That's not an Austrian specialty. In Austria, it's a grade between 1 and 5. And from regular inspections, which usually take place every 10 to 12 years, and in between inspections every 2 years, we get a timeline of the state, of the grade, of the condition grade of an asset, say for in tunnel lining, for example. And from that, we get this degradation line. It's similar with all the technical equipment like ventilators, lightnings. The grading system is a bit different from that, but basically it's the same. And I'm not sure what is meant by the word multiplicative. Maybe Ruben means the interdependence of the assets. So we don't see an interdependence in the degradation between the assets, only in case when we have to touch and replace the assets. We have to destroy the curbs in order to get access to the cables. You have to replace the cable distribution system mostly when you replace major components of other electrical components, for example. And those are all frustrated or stranded costs, basically. I hope that answered the question.
Well, if not, Ruben, I would ask to react in the discussion forum. We can treat the next question from Bettina Geisler. What do you do with very old tunnels where the availability of still existing data is not or no more too good?
Of course, it's also with young tunnels. Say, if the tunnel was commissioned 7 years ago, we only have one grade, and then we looked into it basically only once at most. But basically, not every tunnel. Well, every tunnel is different from another, but they all have similarities. We have a tunnel in rock. We have an unreinforced lining, for example, which is mostly a standard case in Austria, or we have a reinforced cut and cover tunnel, and we have derived degradation models for each type of tunnel lining, for example. It's easier with tunnel ventilators, for example, which are usually more or less the same. And you can use the generic degradation models and translate them from the asset portfolio to the single case. So you don't necessarily have to derive your prediction model for each particular asset, but for the asset class. And then you can help out with that.
And also we want to use this approach for a strategic estimate budgets and allocation of budgets. And for this, I think we can it's possible to go over some lacks of data with or things like that. So we can go, in a portfolio view, it's possible to go over it, I think.
That's very good, Christoph, that you mentioned this, because it must not be mistaken that this tool is not really meant to make a plan or design on a specific object. It's about portfolios, and then finding the budget or the strategy for the upcoming 5 to 10 years or so.
Of course, certainly.
But it's important. So we can be manageable. So we not every tunnel tube is closed down. So we have to know it, and we want to put the money, our budget into the right tunnel and into the right assets. So this system shows us where to place emphasis.
Yes, thank you. In the meantime, Ruben has reacted. So in the specification, so more specially referring to risk of unforeseen closure, and then specifically the consequences. You had a slide on this, calculating the total consequence.
Okay, I think I understand what Ruben wants to point out. Of course, here in this presentation, we try to keep it simple to keep it understandable. But as I said, it's not rocket science. Of course, we have those 52 different assets in the tunnel, and each and every one of these assets has its own probability of failure. And of course, you have a symphony of assets and the symphony of probability of failure. And now you can make the integral, and you can ask yourself: do we have to make the sum of the probabilities, or do they have to factorize it, or do I just take the worst of the assets? We chose to take the worst probability. Decides about the probability of the tunnel system, at least of one tube, and the consequence side, of course, depends on the outline feature of each single asset. Where is it in the network? Is there, as I said, is there a lot of traffic? Is there a diversion possible in the network, and so on? But how to integrate the partial risks of every asset into the entire system, or even the entire network, that's an integration problem solving that's not so easy, but we found to make it the worst case governs the probability of failure for the system of one asset.
Thank you, Christoph and Urs. I see we are out of our questions. I will take the last minute to finalize the Belgian session in this way, that it was an honor for us to indeed to treat the subject of asset management, and especially, of course, in a lot of countries, but certainly in Belgium, we are indeed facing a lot of challenges. We are not in the start. We have already experienced a lot of starting and see what has been done in the past, but indeed we have a lot of challenges to focus on. This was good to have a session defined on this, and first of all, with the presentation of Flora, going into a more management framework for improvement in the transport infrastructure in general, by showing us the possibility of with variety of models to give us a framework. We saw some examples as from the Flemish government in offering a master plan in how to manage asset management through BIM. Through BIM as an example, we show a lot of practical things and show already some results. The next presentation also on FIRS, which is a risk-based framework, as we saw, in how to deal with fire safety in tunnels for decision makers to come to a clear post choices and make their choices out of this. And indeed, we are in Belgium, it's a small country, have a limited number of tunnels. And what was happening in abroad, we got a good presentation of situation in Austria, where indeed we got a good view that indeed asset management is far more than, well, he said that simple project management, but of course, maintenance cycles are coming in, interdependencies we saw. It was a good example to see indeed, to compare tunnels with the structural health and health indeed, visualization by a heartbeat, seeing and hopefully going into the good direction that it is staying healthy in the future. So it gives us a good framework as well to work further on into a future situation and integrate all those experiences into our Belgian project. It was an honor for us, and on behalf of Elvira and myself, I want to thank all speakers for their participation and for the interesting presentations today. And I hope we will see each other, hopefully in a physical condition in some of the coming months or years, to show further progress in all those results. It's really exciting indeed that those challenges are be treated, and we have a lot to do in the future. Thank you very much.
And thank you also from me. Bye-bye.
Bye.
Goodbye.